Hello and welcome to another tutorial. Today we're going to be looking at a containerization technology known as Docker. Now, why would anyone need such a thing? Well, one of the reasons why is because it solves the so-called "it works on my system" problem. Like, I don't know if you ever developed some code and, it works fine on your computer, and then you give it to a coworker or whoever you want to check out your code, and it just doesn't work on their system. Well, Docker solves that problem for the most part. Essentially, instead of using a virtual machine to abstract away the hardware of the system, it abstracts away the underlying software of the system. So when we're making containers, we can take a look at the graph here. Virtual machines versus containerized applications. Over here, when we're using a virtual machine, we can set up multiple virtual machines on the same computer. Each one will virtualize away part of our RAM, hard drive space, etc., etc. And this costs computational resources to do this. Over here, on the other hand, we have one and the same host operating system, which is our main Ubuntu or Windows or Mac operating system, whichever one you're using. Then we have the Docker layer, and then we have different app images. Essentially, these ones have an operating system image along with whatever you're using to actually run the Dockerized container. This makes sharing code a lot easier because everyone can set up a pretty much identical environment with very little resources of their system being used and share that code. Besides sharing that code between coworkers, these things are being used for continuous integration and continuous deployment. When you want to run tests on the code and when you deploy it onto systems like say Travis or Jenkins, and you want to run tests and to build actual applications, you want to make sure that the environment is consistent with what you've been using to develop. And that can be done in a snap, pretty much, with the Docker containerization technology. Okay, without further ado, let's take a look at what we've got here. So, in the Docker documentation, if we go to docs.docker.com, we have the getting started and download and install. Well, you can read up on the getting started, but really you need to download and install the thing. Over here you have the instructions how to do it for Mac, Windows, Linux. In my case, it's Linux. It differs a little bit. Like for Windows, you would have an installer. For Mac, actually, I never really set it up on Mac, but I imagine it will be. You can also download it here. For Linux, it's a bit different. For Linux, you actually select your operating system. So in my case, it is Ubuntu, and then you run some commands from the terminal. Now, there are some limitations when it comes to Docker containers. In particular, those have to do with the video card devices. In general, what I personally use these kind of Dockerized containers is for computational things, like say if I want to run a Python image, or if I want to run a database image, or if I want to run a web server image. That is the kind of thing that I would do. Running Docker images with, say, NVIDIA graphics card installed can be a bit more tricky. There's ways to do it, but it requires a bit more know-how when it comes to Docker. Maybe we will do a tutorial about that later on, but as of now, it's not necessary for what we're using it. Once you're done installing Docker, once you've set this up, once you ran all these repository commands, like this is for old version uninstallation. If I want to uninstall an old one, then over here I need to get the repository set, update my packages, and install these packages here. Then over here access this, update the GPG key, and finally these are the different architectures. This is the regular computer, AMD 64. This is for ARM devices. For example, if you were running something like Raspberry Pi. This is 32-bit, this is 64-bit ARM architecture, as far as I know. You would run the command like this for your desktop, over here for 32-bit ARM, and 64-bit ARM right here. So most of the people will be running this if you're working on your regular desktop, Raspberry Pi, these ones. Once you run this command, you're basically adding the repository to your apt package manager. Over here, install Docker Engine, you update your repositories. Once you add the repository, you have to update it. And after you update it, you install these Docker packages, the Docker C CLI, and Container.io. Once that is done, usually install the latest version of the Docker image, but these ones, there's actually ways to install a specific version, but I wouldn't really worry about this unless you really need one. I would say just use this. Once you're done with the installation steps and you do docker -- version, should add a spacing there, you would see the version of your Docker container. In my case, it's 19.03.12. From here, we can take a look which sort of commands are available to us now. Docker space -- help. And here we see all sorts of different commands that Docker provides for us. We're going to be taking a look over all these different commands, but there's also different sub-levels that you can go into. For example, into Docker images, Docker system, things like that. So in my case, for example, I know that I do not have any Docker images running right now. However, I do have them installed. To check if I have any Docker images running, I'm going to clear this. We can do Docker ps. And right now it says container ID, image ID, nothing. So nothing's running right now. However, if I check for Docker images, there's my images. These are the different images that I have already downloaded from Docker Hub. And actually a few images that I compiled myself for the projects that I worked on before. Another way to do the same command is to do docker image ls. Returns the same thing. So basically Docker image list. That's how this command translates. So let's try and run some sort of image, and let's try to get some other image than the ones that we have here. Let's see what we have. One of the things to know about when you're running Docker is this website here called Docker Hub. Docker Hub contains a library for various software that you might be wanting to use in your projects. For example, if you want to use a MongoDB database, you just type in here Mongo, and we will see the different available images for this thing. So for example, Mongo right here is the official image that we can use in our projects. I already have this image actually pulled down. Now let's see if we can pull some other image. Let's try... oh, what sort of image should we try? Let's try Jenkins. Jenkins is an automation system used to automate various tasks like testing and that sort of thing. We're actually going to be studying this system later on. So we could pull this image down. Docker pull Jenkins. Here we have the code that we can just input into our system. Docker pull Jenkins, let's go. And now you can see it is downloading these packages that are required to run our image. Okay, that took a few minutes. So now that this is done, we can take a look at what sort of images we have now. So let's do Docker images. And now we can see that there's also Jenkins here, which is 696 megs in size. Let's take a look at how to launch this image. Always check the documentation of any particular image that you're about to run. So in our case, one of the simplest ways to run is just to do docker run -p. So you know, -p stands for port, which we are going to be running on our host system versus inside the container. So inside the container, Jenkins is being served on port 8080. And then we can link it to the port 8080 on our local host. This is another port, the port 50,000, to be able to make Jenkins to be triggered from the outside. The port 50,000. Actually, when we go over the Jenkins specific tutorials, I will show you what this is for. For now, all we need to know is host port, container port. Host port, container port. And we can share as many ports as we need. So there's two -p's here. Okay. Docker run -p, and then we are going to link all those things. And let's run this. The container is starting up, and we have our initial input here, which we should use as the password. Now remember this -p8080. If I go to localhost 8080, here we have our Jenkins being served. Now I'm going to input this little initial password that we used. Paste it here, continue, and I can continue with Jenkins installation. All along, this whole Jenkins setup is not running on my host machine. I mean, it is running in my host machine, but it is virtualized away with a Docker containerization system. The way I install it on this computer, I could go into Windows computer and install it in the same way, and it will run inside the container there all the same. Let me open another terminal and list the containers that are being run right now. Here is my Jenkins container. It was started about a minute ago. These are the ports that are being shared to my local machine. And this name has been automatically generated for it. I did not give it an actual name. Let's try and get into this container. I can use its name. I can use either its name or its container ID. Let's just try a container ID this time. Oops. Now we need to enter what sort of command we want to run. We want to run a shell inside this container. So we can either do bin bash, but if bin bash doesn't work, we can just do sh for a regular shell, because bin bash isn't available in every single container image. In this case, it is available. We can see that our regular user and system name has switched to Jenkins at some digits there. These digits correspond to this ID of the container. If we list things here, we are inside of the root directory of the container. This is not my root system. So let's run cat/etc/os release and see what this is. So my main core system is Ubuntu, but now that we're checking the etcos releases, there's actually a Debian Linux 9 stretch. So this is a different, this basically represents the image that we're running, which is obviously a different operating system than the one which I'm running as a host. You could use this containerization system to set up a MongoDB replica set. You could use this same system to have multiple instances of the server to serve your web application, and also a different set of servers to serve your client-side web application. There are all sorts of applications when it comes to the containerization system. And as we continue to develop apps on this channel, you will see a clear benefit to using this sort of containerization technology. Thanks for watching this video. Leave a like and subscribe to the channel. Leave a comment, and I will see you next time. Have a good one. Bye bye.